Various analytical and instrumental techniques are used in the pharmaceutical field. Many of the times, microscopy studies are done to understand the physical properties. Scanning electron microscopy is an advanced technique for the surface characterization or surface study, or you can say the physical study of the particles. These may be the APIs, drug products, and SEM involves study at the micro scale or nano scale for the surface morphology. I welcome all the viewers to this short video on SEM technique and its application. SEM means scanning electron microscopy, and it has many applications in understanding the surface morphology at nanoscale or microscale. Scanning electron microscopy is a technique that use a focused beam of electrons to generate high resolution images of sample surfaces. As the name indicates, scanning electron microscopy, the image is generated using the electron microspray. It has a resolution of 1 to 10 nanometers and a much higher magnification. It provides the surface topography. The output is 2D grayscale image with the detailed surface topography. So how this SEM works? In this, electron beam is generated and focused by electromagnetic lenses. The beam scans over the sample surface in a raster pattern. Interaction between the electron and the sample surface produces secondary electron and backscattered electrons. That's why the detector collects the signals to produce the high resolution image. So as we understood that this technique provides you the surface morphology image, or you can say a detailed surface topography. You can check the APIs or drug products and understand their surface. Also, you can measure the length or you can measure the sizes. Key components of SEM are electron gun, condenser and objective lenses, scanning coils, sample chamber, detectors, and display for the data processing. Sample preparation for the SEM involves drying to remove the moisture, mounting on the metal stubs, coating by gold palladium coating for non-conductive samples, and vacuum sample chamber under high vacuum. Applications in the formulation R&D. So now this slide will provide you the information regarding application and uses. Why SEM can be used in the formulation R&D. So as we know that the particle shape, size or porosity, crystallization or visual appearance, there may be some cracks in the particles or formulations which may affect the quality attributes, and that's why SEM technique is used. First is morphology characterization for the particle shape, size, porosity, agglomeration, because it provides you the image. So from that image you can understand what is happening at the surface of the particle or how the particle shape is there, how it looks like, and then you can interpret some things from that image. Surface texture analysis for the tablets, granules, pellets and the coatings. You can understand the surface of the formulations. Solid dispersion studies identify dispersion or crystallization of drug in the carriers. If you are converting the crystalline material into amorphous, and then if you want to identify the dispersion or crystallization, you can use this technique. Polymorphic identification, so differentiating the polymorphs based on the surface habit can be done. Coating uniformity can be checked. Visual assessment of film coating thickness and the cracks. So minor cracks you can observe. You can check the coating thickness, whether it is uniform or not. You can check the coating thickness by using the tablet samples, or you can use the pellets. You can do reverse engineering of the reference formulation or some formulations, and you can improve the formulations by using SEM. Failure investigations. Cracks, voids, delamination in the dosage forms can be visualized and studied. Excipient characterization. Compare physical characteristics of the excipients APIs by the SEM. Example here I have taken for the easy understanding. Tablet coating defects investigated by the SEM. If you are working onto a functional coating like enteric coating or semi-permeable membrane coating, and you observe the defects, then you cannot check it by using the simple microscope. So advanced technique like SEM can be used. SEM image can reveal the micro cracks and pinholes in the enteric coating, help to optimize coating parameters like spray rate, drying temperature, and by using this information, improve product stability and the performance. This is a simple example. Now see the advantages of the SEM. It has ultra high resolution. It is excellent depth of the field. 3D like images or surfaces, suitable for both API and the formulation. So you can use it in different ways. It can detect physical defects not visible under the light microscope because it has a great resolution and it has a great magnification. Now what are the limitations? It is expensive and require skilled person for the operation. Sample must be vacuum compatible. It may require conductive coating and not suitable for analyzing the internal structure because it can provide you the information of the surface only. What are the complementary techniques for SEM? So SEM can be used with TEM, AFM, XRPD, DSC and the particle size analysis. Different techniques can be used in combination to have great understanding. SEM is a critical imaging tool in the formulation R&D, in the API R&D, in the process R&D, and it helps to understand the particle and surface characteristics. Useful for troubleshooting, optimization, and the quality control. Best when used in conjunction with the other analytical techniques. So you can use it with other techniques and then you can have some conclusion. I hope this information will help you to understand the basics and application of the SEM. Thank you for watching this video and please do like, share and subscribe to this channel. Share the videos to your friends and colleagues and also suggest the topics you want to learn. I will try to make videos on those topics. Also, you can ask queries through comments and you can also mail me. I have given my mail ID in the description of this channel. So you can mail me and ask. I will be happy to help you, to serve you and to provide the advice based on my understanding, experience and knowledge. Thank you.